Welcome to the module Probability of a Single Value. This is Dr. Ellen Gordon. In this module, you are going to learn how to compute probabilities. However, before we do that, it is important to review some basic statistical concepts and theories. In this video, I will review some statistical terms that were covered in previous modules and teach you about two important statistical theories, the normal distribution and the empirical rule. The first statistical term I want to review is a percentile. A percentile tells us the percentage of data at or below a specific value. For example, if I tell you that among College of Business graduates, a starting salary of $52,000 is at the 16th percentile, this means that 16% of students make $52,000 or less. Again, a percentile tells us that the percentage, 16%, of data or students that are at or below a specific value, which in this case is $52,000. We are all familiar with the mean or the arithmetic average. For example, the average business graduate makes $57,000 upon graduation. However, we know not every single graduate makes $57,000. There is some variability. Some students make more, some make less. Often we're interested in what's the average difference from the mean. In other words, what is the average deviation or difference from that mean of $57,000? The standard deviation answers that question. The standard deviation is the average difference from a data point to its mean. For example, if the standard deviation is 5,000, that means on average, a graduate starting salary differs from the mean of 57,000 by 5,000. So the majority of students are going to have a starting salary be between 52,000, that's 5,000 below the mean, to 63,000, that's 5,000 above the mean. The variance is another important term. The variance is the standard deviation squared, or the average squared deviation. For example, if the standard deviation for a starting salary is 5,000, we could just square that to get a variance of 25,000. It is also important to know the difference between a population and a sample. Population data is when you have data from every single member of a specified population. So going back to my starting salary example, if we're interested in the starting salary of recent College of Business graduates, and we have data from every single COB graduate, we would be working with a population data set. Often it is not feasible to collect data from every single member. For example, the COB sends out surveys to every graduate regarding their job prospects, but not every single student can answer that survey. Let's say 100 graduates complete a survey. We would consider that data to be sample data because it's based on a subset of the population. Any numerical value that summarizes a population dataset is called a parameter. This may sound technical, but the mean, variance, and standard deviation, they are all numerical values that summarize a dataset. If the average starting salary of $57,000, if that mean is based on a population dataset, we would refer to that mean, that number, as a parameter. On the other hand, if the mean was based on a sample dataset, we would refer to it as a statistic. It's very easy to keep track of these terms because parameter starts with a P for population and statistic is S for sample. We often use symbols to denote parameters and statistics. You will notice this later on in this module and the next module as symbols are used in formulas. We use Greek symbols to represent parameters and English letters to represent statistics. Here are three common values: the mean, standard deviation, and variance. Again, if they're based on population data, we refer to them as parameters and we use Greek symbols. We use the Greek symbol mu for the mean, sigma for the standard deviation, and sigma squared for the variance. If these values are based on sample data, they are considered statistics and we denote them with English letters. We use X bar for the sample mean, S for the sample standard deviation, and S squared for the sample variance. Another important concept to review is the normal distribution. You may remember this from previous modules. The normal distribution is when you have population data and you plot it out in a histogram and it takes on a symmetrical bell shape. And the mean, median, and mode all have the same value. Now I'm going to discuss the normal distribution or the normal probability distribution in more detail, specifically the three main characteristics of the distribution. The first characteristic you're familiar with, and that's that it's bell-shaped and symmetrical, and the mean equals the median equals the mode. The second characteristic is it can be completely described by two parameters, which is the mean and the variance, or the standard deviation, right? The standard deviation is just the square root of the variance. A lot of times people just focus on or report the mean. However, the variance or variability is just as important. This graph depicts the average age of employees at two industries. In this example, the means are the same, 42, but the standard deviations are different. Industry A has a standard deviation of 5, C has a standard deviation of 8. This means employees at Industry C have a wider spread of age. You can see that they have employees in their 20s all the way up to their 60s. However, Industry A has a much more narrow spread. The average age is still 42, but the majority of the employees are in their 30s and 40s. In the second graph, the two industries have different averages, 42 versus 36, but their standard deviation is the same, thus the spread or range of age is similar. The third characteristic of the normal distribution is that it is asymptotic. This means that the tails or the ends of the distribution go on forever or infinity, and they never touch the x-axis. In other words, there's never a value that is associated with a frequency of 0. Now I'm going to discuss the empirical rule. The empirical rule is an important theory regarding normal distributions. The empirical rule states that if you are working with data that comes from a normal distribution, roughly 68% of the population falls within one standard deviation of the mean, 95% falls within 2 standard deviations of the mean, and 99% of the population falls within 3 standard deviations of the mean. Now note that these are rounded values. Technically it's 68.26, 95.44, and 99.74. However, a lot of times people just refer to rounded values when discussing the empirical rule. Sometimes the empirical rule is referred to as the 68, 95, 99% rule. Here's a visual depiction. Again, you can see that 68% of the data or the population falls from 1 standard deviation below to 1 standard deviation above. 95% is within 2 standard deviations below to 2 standard deviations above, and about 99% is within 3 standard deviations below the mean to 3 standard deviations above the mean. Here's the empirical rule applied to a real-life scenario. For example, a major cell phone provider has determined that their average salesperson sells 100 smartphones per quarter with a standard deviation of 15. Sales are normally distributed. The empirical rule tells us that 68% of employees are within 1 standard deviation of the mean of 100. So that means that 68% of employees sell between 85, that's 1 standard deviation below the mean, to 115, that's 1 standard deviation above. 95% are within 2 standard deviations. So that means that 95% of employees sell between 70 and 130 phones. And 99% are within 3 standard deviations. So 99% of employees sell between 55 and 145 phones. Remember, a normal distribution is symmetrical. So if 68% of employees are within 1 standard deviation within the mean, that means half, or 34%, are 1 standard deviation below, and half, or 34%, are 1 standard deviation above. So that means 34% of employees sell between 85 and 100 phones, and 34% sell between 100 and 115 phones. You probably know that a probability is the likelihood that some event will occur. For example, we know that the probability of getting heads in a coin toss is 50%. We can also view the normal distribution in empirical rule as probabilities. For example, what is the probability that a randomly selected member of the population will fall within 1 standard deviation of the mean? The empirical rule tells us that it is 68%. So going back to our cell phone example, if we randomly pick an employee, there's a 68% chance that they sold between 85 and 115 phones. Please open your prep assignment. Take time to answer the multiple choice questions. I'm not going to review the answers to these questions as they serve a check that you comprehended the material that I just covered. If you're having difficulty answering the questions, please rewatch the video. However, I will review the questions regarding the empirical rule. We're going to be working with a cell phone example. Just as a reminder, the average salesperson sells 100 smartphones per quarter with a standard deviation of 15. Sales are normally distributed, so we can apply the empirical rule. The first question asks, what percentage of employees sell between 85 and 115 phones? This question is essentially asking what percentage of employees are 1 standard deviation below the mean, 85 is 1 standard deviation below the mean, to 1 standard deviation above the mean, 115 is 1 standard deviation above the mean. Again, the empirical rule states that this is 68%. What percentage of employees sell between 70 and 130 phones? So you can see that the chart for the empirical rule states that about 95% are from 70 to 130. And that's because 70 to 130 is 2 standard deviations below to 2 standard deviations above the mean. The third question asks what percentage of employees sell between 55 and 145 phones, and that's roughly 99%. So again, 55 is 3 standard deviations below the mean, 145 is 3 standard deviations above the mean, and according to the empirical rule, 99% of the population, or 99% of employees, are within 3 standard deviations. Question number 4 asks what sales number is the mode? This may seem a little bit tricky, but remember, in a normal distribution, the mean equals the median equals the mode. So the mean is 100, so that means the mode is 100. The fifth question asks, what is the likelihood a randomly selected employee will sell 70 or more phones? You can see from the graph that we have 95% that go from 70 to 130, right? That's the empirical rule. And then we have 2% that's from 130 to 145, and then 0.5% are above 145. So we would take that 95% plus 2%, so 97 plus 0.5, so 97.5. Question number 6 asks, what sales number is at the 50th percentile? Hopefully you remember that the 50th percentile is the median, and with a normal distribution, the mean equals the median equals the mode. So the median is going to be 100. Question number 7, what percentage of employees sell between 70 and 85 phones? Again, if you look at the chart, you can see that 13.5% are between 70 and 85. Question number 8 asks what percentage of employees sell between 100 and 130 phones. So again, we can refer to our chart. We see 34% are between 100 and 115, and 13.5 are between 115 and 130 phones. So 34% plus 13.5% is 47.5%. So almost half are between 100 and 130. Question number 9 asks, what sales number is at the 16th percentile? If you remember, a percentile is the percentage at or below a specific value. So we want to figure out what sales number are 16% of employees at or below. In other words, what sales number is associated with the bottom 16%. So if you look at the chart, you can see that 55, the sales number, 0.5 are at or below 55. So that means 55 is at the 0.5 percentile. 70 has 2.5% below. So that means 70, a sales number of 70 is at the 2.5 percentile. Now let's look at 85. 85 has 13.5 plus 2, which is 15.5, plus 0.5, which is 16%. So there's our answer. 16% of employees are selling 85 phones or less.